Now in this video we will estimate demand equation using multiple factors. So in the previous video, which you can find in my channel under the economics for business heading, there's a folder here basically on this channel, so find that and please watch that before watching this. So we will continue estimating demand, this time with multiple variables. In the previous video it was single variable. So we will be using the same data that I used in the video there. So again, the dates, and then sales is the quantity of pies sold in a given month of the year 2003. The price is the price of this pie per, basically price per pie, which is £6.39. Advertising is the advertising expenditure in this month by this company. Competitor's price is the price of the pie sold by the competitor, and income is the income per capita, income per person in the region, and 4 million is the population. And this is the whole data. Well, interestingly, there's a big drop in the population. So this is a huge increase in population and then big drop in a year. So no idea why this is so, but this is some sort of an immigration thing, and suddenly 2 million. So this must be some big event that caused this huge jump in population right here as well. So this is a made up data, so this is just an example, so we can ignore for now, but this alone will cause a lot of different troubles in regression analysis, but we are ignoring them for now. Okay, let's estimate and get the job done. Right, so we go to data for that. So we need the multiple regression tool pack for now. We don't need, I mean, we cannot use single regression now where we looked at sales and price. We couldn't, I mean, we won't be able to use the same method that I described in the last video. So for that reason, we will go to data analysis. So through data ribbon, data analysis. If this is not there, please Google analysis tool pack, how to install analysis tool pack, and then it will explain you how to do this. You'll be able to find sources, but this thing is not typically there on Excel spreadsheets. You'll have to install it, and it's free. You could do that if you just Google how to install analysis tool pack. So click that, and don't forget to put your cursor here outside the table again. And here it is. The list gives you these different functions. We would like to have the regression. Okay, click on it. Okay, now this contains the information from what I just looked at just before the video. I had a look at this data and see how the regression would look like. So what I did here is I'm gonna redo everything. So first thing is input y ranges. So this is the dependent variable input. So dependent variable in our case is the sales quantity, so highlight all of it. Done. Independent variables are the input x ranges, so this would be all this. Ignore the time for now, we don't need it. We are not interested in technology, so we don't include it. And once you finish highlighting dependent variable and independent variable ranges, don't forget to labels, tick these labels, because the first line is our label line. If you do not tick this, the Excel will consider this as numbers, as digital sorry, as the input, data input, but it is not data input, it's just labels for each column. So labels ticked. Next thing is tick the output range. Here I specified already is the J2 cell, so that's there. Now we don't need any of these. I have video on how to use this or what they mean in the business statistics folder on this channel, so if you want to watch it and learn about regression analysis, you're welcome to do that, to watch these videos. So okay, and as you can see, it's a very quick solution here, very quick output. Now this is the regression output, and we don't need all of these. All we need is the adjusted R squared at the moment, and then this estimated coefficients. These are coefficients, and these are names of these coefficients. So these are variables. Remember the price, advertising, competition price, income, population. Now this is a multiple regression, so I have to write the equation here by copying from here into a certain sort of the writing tool here, which allows me to describe it in a better way. So let's do this. So let me train it, because it's the first time after a long time that I'm writing using this pen tool. So what we have here is coefficient estimates of each variable that we used as dependent variables, independent variables. So in this case, the dependent variable was sales, so just sales equals, this is the intercept, so I'll have to write all of this, 617,437 minus, so that's this minus here, 12,8,020 times price P. This is the price. So the price there plus 5.8 times advertising A plus, so I'll continue here, 28,321 times the coefficient estimate times the competitor price, so CP, plus 1.7 times income, plus the last one is the population times the P. Now there is error here, which I am going to ignore. You know, you remember from the class, this was epsilon. So because we usually have issues with estimating exact curve, so there's always room for errors, so we account for it by writing the error term, but I'm ignoring it for now, so just ignore it for now. Now this is something you will see in your case study as well. I think it's a market for butter case study, and some of you emailed me to asking how we could use or how we would do this case study. It's basically similar equation here as well. In the case study they have fewer variables. In this study we have a little bit more of them, like 2 more variables. I think in the case study there were 3 independent variables, price, income, and something else, but here we have more variables, including the population, including the competitor's pricing. So anyway, let's get on the job and think about interpreting the results. So first of all, what we usually estimate this is for forecasting, but we don't do forecasting for now. We start with interpretation. Looking at this part here, the part with the intercept and the price only. If you plug in 1 here into price, which means which basically implies increasing the price by £1, then our quantity demanded will be declining by 128,020 units. It's a huge decline if we increase the price. And this is, again, the data is just telling us that there's a negative relationship between price and quantity demanded, as we discussed in the class. Theoretically, they are negatively correlated, and this is the case here as well. So increasing the price by 1 unit or by £1 leads to the results in the decline in demand by this many units. So 128,020 units, huge decline. Similarly, if you look at this coefficient here, 5.8A is advertising spending. If we increase the advertising by £1, our quantity demanded increased by 5.8 units. So let's say 6 units of pie. So that makes sense, because the more you spend on advertising, the more advertising you will be doing. So higher the advertising spending, higher the awareness of the product, and higher the quantity. Similarly, competitor price, if it increased by £1, we will have a demand increase in our sales in the form of sales quantity, 28,321. And that also makes sense, because if the competitor raises the price, then people will switch to our pies, or this company's pies. I'm thinking I'm owning the company, but in any case, I hope you understood this, that this increase in competitive price leads to a positive increase in our sales, which is correct. Well, theoretically and practically, I should say the data is also telling us this. Income. So if income increases by £1, it looks like will pie sales also increase about 1.7 units, so it's about 2 units. So that makes sense again. You know, as we get richer, we could buy more pie. So this is normal good. If this value was negative, with this pie would be in general an inferior good, but this is a positive relationship here, so it's a normal good. Plus the population parameter, 0.02 times the population value. So if we increase the population by 1 unit, then the sales of pie increase by 0.0 units, 0.02. So it will be better to have 100 people as an increase unit. So let's say if if the population increases by 100 people in the region, then we can sell 2 pies. So it's 2 pies per 100 people increase in population increase. All right, so this is how we interpret this demand equation. At the moment, this is not telling us what the elasticity of demand with respect to price or advertising or income, because this is not the log-log regression. This is simple regression in original units. So in the next video, I'll describe how elasticity of demand with respect to factors can be estimated. So we will also learn about that as well. So I hope this was useful video and helpful. And by the way, one thing, r squared. So in this case, we'll take the adjusted r squared, not r squared, because at r squared is only when you have one what you call this deep independent variable. So it could be used in the previous video. So if the regression analysis was s equal to a plus, sorry, this is not advertising a, this is just a, b times x. So if this was only one regressor in the model and is being regressed on sales, then we could use the r squared to interpret goodness of fit. But because we're using multiple factors, price, advertising, competitive price, income, and price of the population, then we will be using r squared, adjusted r squared. So that is 0.88, which means basically a very good fit to the data. So this regression model is accurate, or more or less to some extent is describing the quantity of sales accurately. So in other words, I could say here, in terms of the language of the statistics, that 88% of variation in quantities of sales or quantity demanded is accounted for by all these factors jointly: price, chance in advertising, chance in quantity price, competitive price, income, and population. So this is a huge improvement from the last previous videos results, right? So that's the interpretation of this output, and hopefully you will benefit from this watching this video, and maybe something in the exam may come up when you take midterm exams and finals. So make sure that you learn how to interpret the how to use the quantitative analysis in business decision making. It's relevant to the subject, and it's very important as well, especially in demand estimation. Okay, and see you in the next video then.